What do I know? What do you got? I know the x-intercepts. Why is that important? Why is knowing the x-intercepts important?
Tells you the degree.
I already knew the degree was cubic.
Yeah.
You know what I mean? So I know that this is going to be a 3-degree function. But why does knowing that I've got -5 there, 1 there, and 3 there, why is that important? Don't know. Why is that important? Those are x-intercepts, right? They're the zeros, okay? Fantastic. So I've got zeros here of -5, +1, and +3. I'm trying to make a function, right? Okay. So let's go side note here. Back when we were dealing with quadratics, how did we do that one? If we had zeros. Okay, so what was intercept form? A times x minus r sub 1 and x minus r sub 2, right? Right? Can I apply that to this one? Okay, so if I've got zeros of -5, +1, and +3, what does that mean? If I've got zeros of -5, +1, and +3, what does that mean?
Can you put it in the same form
Like, what do you mean, same form?
as the intercept form?
So what would -5 transfer into?
X plus 5.
And what would I call x plus 5? Rhymes with tractor. Factor. Why are factors important? Over here, we had 2 factors. X minus r sub 1 and x minus r sub 2. Why were those 2 factors important? They find us the x-intercepts, they find us the zeros, but they also give us the... They give us the function, okay? So if I've got a factor of x plus 5 that relates to a zero of -5, then what would my next factor be? X minus 1. What would my next factor be? X minus 3. Okay, fantastic. Now, going back to old school. Here, what did we do then? Wrote them out then, right? What am I going to put in between them? Am I going to add them? Am I going to subtract them? I'm going to multiply them, okay? So my f of x here is going to equal a, because I'm going to have some a value there, times x plus 5 times x minus 1 times x minus 3. Right? Now what? I can't multiply them out? Don't need to. That's busy work. What? How am I going to figure out a, Megan? No clue. Okay, let's go back old school then. How did we figure out a here? You plugged in a point, right? A point that the function goes through, right? Okay? Any point that the function goes through, as long as it wasn't one of the zeros. Right? Okay? So I can't plug in -5 for x, I can't plug in 1 for x, and I can't plug in 3 for x. What else could I possibly plug in for x? Izzy? it gave me a point right here. Okay? Gave me that point right there. So I'm going to plug in what? Or where am I going to plug in 0? For x. Where am I going to plug in negative 30? F of x. Okay? So that now then looks like negative 30 equals a times 0 plus 5 times 0 minus 1 times 0 minus 3. With me? 0 plus 5. 0 minus 1. 0 minus 3. A times 5 times negative 1 times negative 3. How much? 15a, right? Okay. So negative 30 is equal to 15a. I have no idea how you got negative 750 out of there.
I put the negative 30 in the A spot.
Okay. Okay. All right. Now what? Divide both sides by 15. So I get negative 2 equals A. Knowing what you know about a cubic function, does this cubic function that we need have an A value that's negative? Yeah, because the right side is going down. So we need a negative A value, so that matches up. So f of x here is going to equal negative 2 times x plus 5 times x minus 1 times x minus 3. Now, I am cool, Kruger is cool, with leaving it like that. Okay? If we asked you, though, to write the polynomial function, this is a factored function. If we ask you to write the polynomial function, then you'd have to multiply it out. Okay? Right? But if we don't ask, factored form is just fine. Okay? You probably have to try a little more space. Okay. Okay? We're out of the textbooks today then, too. We're going to start on page, I want to say it's 320. Yeah. So, we're going to start with problem number 2. Normally we start with problem number 1, but I'm in one of those moods today. Alright, so problem 2, there's nothing average about this rate of change. The cubic function p of x models Zorzanza's total profits over the first 5 years of Zorzanza being in business. Okay? Right? I just like saying Zorzanza. Right? Sounds like a pizza place. Alright, we're making pizzas. Well, that's what I was asking about before, sister. Okay? Alright? Alright, and we're back. So, Zorzanza's profits. Now, let's talk a little bit about Zorzanza, the fabulous pizza place. Okay? We had a profit model like this before. Actually, we didn't have, it wasn't a profit model, it was a volume model before, correct? Okay? And we had some restrictions on it. Actually, one of your test questions from yesterday, we had some restrictions on the volume, right? So let's talk now about Zorzanza and their business profit model, which is what we have pictured here. Okay? Discuss for me now things that you see that you notice about Zorzanza. Does all of it make sense? What'd you say, Nick?
Down in years.
You mean they're going down in years?
No, they just put that for like the
Oh, I see what you're saying. Way down at the bottom? Yeah, okay. Yeah. So they're saying the X is years. Okay? Alright? Does it all completely make sense? And if so, what makes sense about it? If it doesn't make sense, let's talk about it. What you got, Maddie?
It's not an accurate.
So they
Like,
started
why they,
negative.
What do you mean it's not an accurate graph?
like why would they use this?
Because this is their profit model. Okay? Profit models aren't necessarily all rosy, peachy, and keen. Matt,
They started off with negative money, like they,
does that make sense?
yes.
Why does what we're saying here is, why does it make sense that we have a y-intercept at 0 years?
Lost money.
We're making negative $200,000. We'll go with Megan first.
because like as you start a business, you have to put money into like all the other types of things. That
The
go
startup
along.
costs and getting space. If we're a pizza place, we got to buy the restaurant. We probably got to buy the pizza oven because we ain't just using no regular old oven. We're using a brick pizza oven because that makes the best pizza. You know, we got to get the pans that, you know, because we can't just, you know, spin it up into the air and magically it, you know, comes down cooked. You know, what else?
So then if they have like a starting point, shouldn't that just be like a starting point, not an arrow going down?
So,
that part,
so what part doesn't make sense to you?
like that they keep going negative.
This whole area over here
Right.
is not applicable, right? Because we weren't in business negative 2 years ago, right? Our business started at year 0, right? So that whole side of the graph I can ignore. Okay? It's just on there because the function that we would come up with if we were to come up with this function, we're not at the breaks. But if we were to come up with this function, like we just did, okay, it would still be over there. What else? Any other spots that don't make sense? Go ahead.
After like a year and like 9 months ish, they start to lose all the money, but then at like the 4 and 3 months
Okay.
point, they start.
So now let me ask you this question. What is this function displaying? What are we looking at here? Profit. So Ken Zorzanza's Pizza Hut. I don't want to know can't use Pizza Hut. You got to come up with a good name.
Pizza place.
Pizza Shack.
Well, Pizza Palace was from Toy Story, though.
Oh.
Pizza Hut.
Pizza Shack. We can't use Pizza Hut. That's trademarked. We'll get in trouble.
Pizza House.
We'll be like down here in profits because we're paying our legal fees. Okay?
Pizza House.
Pizza House.
Chef's
We need a
Zorzanza's
Z.
Pizza
We need
House.
a Z word. Something. Zorzanza Zen of Pizza. Yeah. Zorzanza Zen of Pizza. Okay. All right. Okay. So Zorzanza Zen of Pizza. Can Zorzanza Zen of Pizza lose money over a course of a certain amount of time frame? Yeah. Businesses lose money all the time, right?
A new business comes in across the street.
Exactly. A new business comes in across the street. Rosati's opens, or whatever the one, the old Pizza Hut place just opens. You know what I mean? That's going to steal some business from us over a certain amount of time. Okay? So can we have negative profits?
Yeah, because you spend more than
Yeah, we're spending more than we're making. Okay? So that's good. I'm okay with that section below the x-axis. Okay? Luckily for Zorzanza Zen of Pizza, we rebounded and then we started making money. Okay? Right? So, what I would like you and your shoulder partner to do right now is I would like you to answer question number 1 on page 320. That's A, B, C, D, and E on for question number 1.
Yeah, I went back down. Okay, so
4.4.
All right. Oh, come on now. There it goes.
yeah.
I want that one. I want that one. I want that one. And I want those two. All right, so 800,000 is what I'm looking at. So I go across at 800 because my profit is in thousands of dollars, and then when it intersects, then I drop it straight down like it's hot, if you will. Okay, all right, and then as long as I'm here, I'm going to do the 200,000s right away. Okay, so at 800,000, we should have something a little bit more than 4.5, right? But not quite 5. So let's go with 4.55 years. Okay? Because my blue line comes down here and it meets, so these are it goes by 0.5s on my scaling there, and I'm just to the right of 4.5. So I wouldn't go anything more than 4.6 on that one. So it'd be somewhere between 4.5, 4.6 in my estimation. Okay? 200,000, I would estimate that at 0.5 years, again at 1.4-ish, 1.45-ish years, and again at about 4.25 years. Yes? Okay. Gotta adjust my one. This one. Oh, now. Close enough. Okay. Somewhere in there. With me? Okay. Next one says greater than 200,000. Well, so that's going to be above my horizontal one. So that's going to be between. Whoa, 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 whoa. So that's going to be from 0.5 to 1.45 years. And after 4.25 years. Yes? Okay. When I am above that line. When is the company losing money? Well, looks like we're losing money from 0 to about from 0 to about 0.25 years. We're in the negative. And then from 1.75 to 4.25. Wait, this one should have been, so then this one should have been a little higher then. This one should have been 4.4 here. Let's adjust that one to 4.4, which adjusts this one to, whoa, whoa, tap the brakes. That one to 4.4. So then, and here, from, what did I say? Losing money from 1.75 to 4.25. Okay. So then when is the company making a profit? From 0.25 to 1.75 years, and after 4.25 years. Agree with all that? Okay. So what we're looking for is on these two, or excuse me, on these two up here, where it's we'll call it level. So on A and B, it's where it's at 800,000 or where it's at 200,000, where it's at that level, where the function is at that level. Part C, where it's above that level, where the company's losing money is below the x-axis, where the company's making a profit would be above the x-axis. Okay? We're going to skip page 321. We're going to go right to page 322. AROC. Okay? The average rate of change of a function. Now, I'm going to get all mathy on you right now. Okay? The average rate of change. I got to change. I got to go into my math teacher voice now. Okay?
The average rate of change of a function is the ratio of independent variable to the dependent variable over a specific interval. The formula for the average rate of change is f of b minus f of a over b minus a for an interval a to b.
The expression changing. This should be b minus a. Misprint.
It is changed.
It is changed on yours?
Yeah.
Well, good. They made the change then. I took this from last year's book then.
Okay? The expression b minus a represents a change in the input of the function f. The expression f of b minus f of a represents a change in the function f for the input and change in a to b.
All right, so that's what that is. Okay, that's math talk. Let's talk now real world. Okay? What is average rate of change? What's the average rate of change? What mathematical concept is average rate of change? No. Mathematical concept is average rate of change. I can't say average, okay? Because the average of two numbers is you just divide by, you add them up, divide by 2. I'm not adding and I'm not dividing by 2. What's rise over run called? Slope. Remember these things right here? These little thought bubbles? They give you hints. Okay? Okay? So you've already calculated average rates of change when determining slopes. When you guys came to school today, some of you drove, right? Okay? And there's that little dial thing on your, most of you had a dial, some of you got a little digital readout, I'm sure, but that dial thing went up and down like this, right? Or actually for you guys it went like this. Okay, right? Okay, what did that do? Shows you your speed, right? Speed is how fast you're going. It's how fast you're changing, right? Okay? So that's a rate of change. Okay, it's speed. It's miles per hour, miles per gallon. My car calculates the my average fuel efficiency, miles per gallon. Okay. Okay. It's the change in y divided by the change in x. Okay. That's what average rate of change is. Now you will hear me refer to it from now on as AROC. Okay? AROC, average rate of change, AROC. Okay? Okay? So, let's go back to Zorzanza's Zen of Pizza. Okay? We can determine the average rate of change for the Zen for the time interval 3.25 to 4.25 years. Well, what I need from that is I need this point right here, which is 3 4.25, comma, negative 600-ish. It's a little bit more than negative 6, or a little bit less than negative 600, but they just made it be negative 600. Okay? Then I also need this point, which is the point 4.25, comma, 0. So if I'm going to calculate the average rate of change there, I'm going to take the y's, and I'm going to subtract them, and I'm going to divide that by the x's subtracted. Okay? So that's what they did here. They took the y's, so they took the y's here, they went 0, okay, so they went 0 minus negative 600 all over, and then here I wish they would have put 4.25 minus 3.25 right there. Okay? Which is 1. Right? Okay? So we get an average rate of change of 600 there. Okay? The average rate of change for the time interval 3.25 to 4.25 is approximately 600,000. I'm confused. How did we go from 600 to 600,000?
Because the rate is in thousands.
Because the what?
It's in thousands.
The what? What's in 6? What's in 100? What's in thousands? The Y. The Y. It's an S word. Scale. The Y scale. Okay. That's not the only place that I'm confused about this, but but it's the next first question. Explain why the average rate of change is 600,000 per year and not 600 per year, and you just answered it. The Y scale is $1,000 per box. So as you go up, each box, each tick mark, if you will, is 1,000. Okay, with me? Actually, yeah, or it's the Y scale is 1,000. I shouldn't say per box because it's actually 200,000 per box. Is in thousands of dollars, right? Does it say, what does it say on the thousands of dollars? Yep. Okay, with me? Okay. My next spot of confusion is this. Let's go back and let's look at our graph on that part. Okay. My next spot of confusion is this. Why is this, on this particular interval, why is it positive? Because we're not making money, right? We're losing money because I'm below the x-axis. Why is the average rate of change positive?
Because of the other points on the graph?
Nope. Because what you're doing when you're doing average rate of change is you're saying that, I'm trying to think of how I can do this. You're blocking out all of this. So you're just looking at that part right there. You're not looking at anything else in regards to the function. You're just looking at that point right there. Okay? So we're below the x-axis. Why is it positive? What's increasing? How do I know, Megan, that the function is increasing on that interval?
You're going from 3.25 to 4.
That doesn't tell me that the function is increasing. How do I know that on that particular interval last week. How do I know when a function is increasing?
A value. Degree.
I can shout out random
When the
words
lead
too.
I try my best.
How do I know that a function is increasing?
Like it's super easy.
It is beyond easy. I got it ready to go.
Because the line is going.
Here, I'll even do it this way so you're not confused. Okay? I got it still ready to go. For those of you watching on the internet, I have my finger out. How do I know that my function is increasing? That's not increasing. Going down is decreasing in everything that I do. How can I use my finger and determine if a function is increasing? What do I do? Trace my finger on the graph. And what happens? If my finger moves up, the graph is increasing. If my finger goes down, my function is not down, decreasing. Okay? So as I'm going to the right, this is working left to right here. If my finger goes up, my function is increasing. So if I start on the left side of this interval, my finger is going up as, I'll draw it here in green. My finger is going up as I'm going to the right. So my function is increasing. Relate it back to you driving to school this morning. Okay? If your speed is increasing, what's happening? You're going faster, right? And you're going faster. Okay? So your average is increasing if you are going faster. Okay? So that is why, here now, why is the change positive over this interval? Because the function is increasing on that interval. What does the average rate of change represent in this problem? The what? Profit over, in this case it's years, but really it's profit over time, right? Because we could break it down into months if we wanted to, or half years and stuff like that. Yep. So it's profit over time. A rate of change compares two quantities. Okay? Usually, one of the quantities is a distance or a value of some kind, and the other quantity is normally time. Okay? My shower has a gallons per minute flow rate, or gallons per hour flow rate. I can calculate that. Okay? My toilet, when I flush it, has a gallons per flush rate. Okay? That's what they're rated on. Okay? My car has a miles per hour. That's a rate of change. Okay? I'm trying to think what else. Miles per gallon. Okay? Is it one where it doesn't involve time? Okay? Right? With me? Okay? So, my task for you now and your shoulder partner is determine the average rate of change for Zorzanza Zena Pizza's profits over the time interval from 1 year to 3 years. Before you do that, let's take a peek at Zorzanza's profit on that time interval. Oops, went too far. Okay, so from 1 year to 3 years, what should your final answer be? Why should it be negative? Because it's decreasing on that time frame, right? Okay, figure it out for me. So, in order to determine the average rate of change of Zorzanza's profits on that time interval, what do I need? I need the points where they're at, right? Okay, so at the first year, what is Zorzanza's profit? About 300? I would go with about 300,000. Yeah, so I'm just going to go 300 there because it's in thousands. So y is in thousands. Okay? What else do I need? I need the 3-year profit. What's the 3-year profit then? About negative 600-ish. Okay? All right? So from that, then I need to calculate average rate of change. Now, the nice thing, just the same with slope, when we were doing between points, that slope is never going to change. If I start on the left point and end at the right point, or if I start at the right point and end at the left point. So it doesn't matter which one of those you go first, as long as you remain consistent with your points on top and bottom. And so then that would be 1 minus 3. So this would be 900 here over negative 2, which is negative 450. So my average rate of change, my AROC here, is negative $450,000 per year. Okay. Follow-up question, we'll call it question number 5. Find me the AROC on the interval 0 years to 4 years. Okay. Find me that AROC from 0 years to 4 years. What do I need? I need the points, right? Okay, so at 0, what is negative 200, right? Okay, at 4, it's what? At 4? At 4? I got like negative 250.
Oh, yeah.
You know what I mean?
Yeah.
Yeah, ish, because it's not quite half, right? I'm going to go with negative 250. Okay? All right? So, that's going to be negative 200 minus negative 250 all over 0 minus 4, which is 50 over negative 4, which is negative 12.5, right? Right? So that translates into my AROC being negative 12,500, correct? Dollars per year, right? My function could do whatever it wanted in between that point and that point. Here was at year 0. Here was at year 4. my function went up, came back down, and came back up during that point in time, right? But because I am looking solely at the 2 points, I'm looking only at the slope of that red line. That slope is negative because it's going down. With me? I don't care what my function did in there. My function could have done all of this crazy stuff in there. Okay? But I'm only looking at those 2 endpoints. That's all I'm looking at. I don't care what the function is doing in between there. I'm just looking at the 2 endpoints. Okay? When you came in today, don't be picking up, don't be that rude. Okay? When you came in today, you got a blue sheet. That blue sheet is the 4.1 homework. That 4.1 homework is due tomorrow. Okay? Have yourselves a great